I'm the development engineer Xuhaihua from KubeCon CloudNativeCon, and I want to share with you how we operate the biggest Vitess clusters in the world. Next, I'm going to introduce from 4 aspects. First, why we choose Vitess. Second, how we operate Vitess in JD.com. And next, my colleague Shi Jinke is going to introduce the plans we use and also our future plan. First, why we choose Vitess. First, what is Vitess? Vitess is a database clustering system for horizontal scaling of MySQL. So what it's working on? It's working on dividing the database, but not just dividing database. This is the structural map of Vitess. And we can see the application is application nodes. It could be several nodes. And through the MySQL protocols to connect to other nodes. And the application going to send a query to the gateways, and the gateways are going to dispatch through the other DNS, and there were also the key nodes, and using the ID as the. And originally, the table used in a different way, and now we can divide these keys utilizing the ID protocols and putting them into 3 databases. And in this way, we are able to divide the database in different parts, and including the MySQL, and also with tablets we can take it as a shard, and then in this database there are 3 shards, and in the original key tablets we can put it into 3 nodes, and we also retrieving the division of the original database. And also there is a topology services as well, including all those all the tables are going to divide it based on different fields, and all of these will be recorded into topology. And also we have other tools for operation. There were VDCTL and also VTCTLD. It's providing the external functions. Originally, for example, I have some shards already. I want to add some extra shards. However, I want to change for the other nodes. For example, I want to download or upload a nodes, then in this way I can use the VTCTL to operate it. So this is the major structure of Vitess. It's mainly for the dividing of the database, but it's beyond dividing of this database. And we have several concerns, it's because we have several factors to consider when we choose the Vitess. There were several characteristics. First is MySQL. It's well proved inside JD.com, and also we have a lot of experience on operating MySQL. So that's why we choose these database operation methods, and we will feel very confident in this bottom layer of it, fundamental layer of it, because inside JD.com there are a lot of the other services using MySQL database. Even now we want to migrate it, we are using MySQL, and it just needs a little bit modification, so the cost of migration is very low. The third query means I have a lot of data in some database. It may be more than billions, but now I want to put this data on a big data platform to do some analysis or the downstream operations. Usually, if we have just a very small amount of data, we will just use this lab and then use some of the nodes on our gateways, and then this will be shown on our big data platforms. However, when we have a lot of data, for example, it's more than billions, then I will put all this data into the nodes, gateways, and this will cause some problem within it. If with this big amount of data, I will just read part of it to the gateways and put it on the platform, and then later I'm going to write it on the big data platform. It's utilizing the streaming operations. And of course, the streaming operations means the whole train should be floating, and there should not be any blockage at any of these nodes. So all of these nodes should be able to manage this kind of stream operations. And next is sharding and the two-phase commit, and also the secondary Windex. And for the next three parts, I'm going to talk about it in details. Resharding is doing the data segregations. For example, originally we have 2 shards, but there were too many data, so I need to divide it into 4 shards. So we are able to use resharding to do that. And next is the two-phase commit. It can ensure its atomic commits and also to avoid any of the replications during the commits. This is also one of the highlights of the Windex functions. First is resharding, and we have separated several steps for resharding. First, it's copying the data. We can take it as one shard, and within one shard there are the master and also the replicate. You can see the structure here. I want to take one of the replicate from the connection. So this connection has been disconnected, so there is no relation between these two. So this is a drain here. It's a snapshot data. Originally we have a table and we use the ID to divide it. And I want to take a very simple rules on the sharding, on the segregation. So I will to disassemble them based on the ID rules, and also utilizing the stream query to check it and then put it into these shards. If with this ID, I will put it in this shard. Without it, I will put it in the replica. So in this way, we can deal with the screenshot data, and during the copying process, the master data is always writing in. It means that there is some of the delay between the master and the replica. So I want to replace this replica because there is some delay of the data. It's going to synchronize some of the logs, the bin logs, and Vitess are able to synchronize these bin logs and then to analyze it and convert it into circle. And all of this writing and updating will be synchronized to the shards that we have decided to. And it will relate it to the operations of the whole clusters. So without this master and replicate relationship, the two parts should be synchronized. Otherwise, it will have some problems. So what should we do? And then for the original shards should stop service. And we are going to use two new shards to work on it. And originally it's routing to these shards, and now it's routing to the other 2 shards. It's just you need to use several seconds. So the resharding just affecting the whole clusters by just a few seconds. This is the sharding system. We have been working on this resharding process for many times already inside JD.com. And here is another Vitess transactions. We have 2 phase commit. And I will first focusing on multi-shard. And there is one question that it's deviated from the multi-shard. It's too simple examples here. It's also it's using the ID for the sharding. If it's less than 512, if it's less than 512, I'm going to put it into shard 0, and for those that are not, I will put it into shard 1. And also, I will have another terminal, and I will provide a quick verification. So for those ID less than 512, I will put it in the shard 0. If it's 900, it means it's larger than 512, so I will put it in shard 1. If it's 400, I will put it, because it's less than 512, so I will put it into the shard 0. And at last, I'm going to do the commit operations. And the shard 1 has been succeeded in commit. However, the shard 0 maybe have some failover and also have some weird or abnormality. And when the shard 1 doing some commits, it means that it will be unsuccessful. It will cause some of the rollback. So we will see some of the problems from it's because of the terminal, the client's terminal that makes this failure. And shard 1 is successful, but shard 0 is failure. So, however, overall, it has caused the failure of the commit. But it still need to see the scenario of this. If you cannot accept partly commit, then there were two results you can adapt. First is single shard. All of the data can only be included into one shard. You can put it in shard 1 or shard 0 if this has have some failure, then it will tell the clients and also to report the error. And the second is two-phase commit. The second way to solve this problem is two-phase commit. It means all of these operations will first record it on the logs, on the cloud logs, and then before it's submitted, the machine has some problem, and we need to wait for the reboot or the recovery. Then it's going to get into the reblock phase, and it's going to implement this result. And later we will find that data has been committed. So through the reblock, I'm going to report this error again. So this is the framework used by Windex. We also once made a scenario. First, TPS is very high. This is an example, and also we use the Cape AS. So, but there is some problem with it. The KAS think it has some problems. And Kubernetes will reboot these nodes and always rebooting it. And because its TPS is very high, so that will cause the partly commit problems. But it will be solved by the two-phase commit. Of course, the Kubernetes, we should deal with the bugs on the KPS. The KAS. And the second of the Windex. So what is the functions of this Windex? On VT-gates, they will use the VT table as its routing. If ID from 1 to 10, put in shard 0, and for the other part, put in shard 1, and for shard 2, and we're going to make it for another part of the number, the name ID. So ID is 1 and 5, and name is like 5 and Lisa, and later I insert, and the ID is 11, and the name is Lisa. The two names are both Lisa, but it has been put in two shards. However, when I do the inquiry based on the ID, for example, then it's going to say the ID is 5, then it's going to route it to shard 0. Because I use ID for sharding, and then it's going to route me to the shard 0. Sometimes I cannot provide this ID. For example, I can only use name to do the query. Then If the name is Lisa, if we use the name for routing, then what should we do? On all of these 4 shards, we are going to query all these 4 shards again once. Although it did not find it on shard 2 and shard 3, and we still need to check it.
So this enlarges the reading. So how did Vitess cope with it to avoid the enlargement? Upon insertion, the IT equals 5. I also saved the correspondence relationship between Lisa and 5. So when Lisa is equals 1, then I can check the result very quickly. So I'll search it on this table, in this table first, where Lisa is 1. So we have ID 5 and ID 11. And I only need to search further in shard 0 or shard 1. So I don't need to check all 4 shards, so as to avoid, unnecessary reading and access. If there are 4 shards or even 200 shards, then it's there will be very significant latency observed. Second, I'd like to talk about how we run Vitess in JD. This is our internal architecture. So through MySQL protocols, it's connected with our VT gate, and the VT gate through gRPC to connect with our shards. The VT shards encompasses the VT shard and VT tablet, 2 components. And the feedback queries, we feedback to eventually to the apps, and VT gate through the watch mechanism. We're using etcd to enable the original data storage, and VT data have a watch mechanism which will real-time watch the root information and other changes in original data, so that the data can be synchronized with our shards to enable a more efficient synchronizing. And many JD businesses have internal memory requirements for based on our MySQL operation for TB business, for example. For some scenarios, we need to real-time synchronize the data on our big data platform by extracting the bin log to synchronize it with the big data platform. In JD, we have a bin log service. We real-time synchronize the data through Bin Lake, and the Bin Lake will offer subscription services for the users, so as to enable real-time synchronization of data. In JD, there are 4 key systems. One of them is still under development, which is a backup system. Real-time backup is still under development. The third one is already being applied online on a massive scale, and I will focus on the 3 services. First one is JTransfer. What does it mean? So many of our previous services we use MySQL directly, and now if the Vitess is online, so we are switching to Vitess to transfer some of our services. So we real-time extract and synchronize VT gate data, Bin Lake data. This is only limited to this stage to enable real-time synchronizing. And there is no master replica latency. It is similar to what I have described. So this business module used to visit MySQL module. Now it only needs to visit the new module. They only need to restart the services. It used to connect with MySQL cluster, now switching to Vitess cluster. So this is what we do for transfer. It's mainly used for the key accounts of big businesses in JD, where there used to be many nodes, many data. So in this way, we don't have to consider the storage space. In the past, maybe there are 32 shards, and we have to expand the key space by ourselves. It's very difficult and time-consuming. Now we're using Vitess key space. There are no problems for storage at all. So this is what we use internally. It's also part of Vitess component. It's called orchestrator. It's open source to Harvard. We call it OLC. So on the left side is the OLC cluster, on the right side is a Vitess cluster. The orchestra cluster will regularly, like every 10 seconds, to retrieve the data from all nodes, MySQL nodes, their master replicas, data, their latency, and after the retrieving, this data will be moved to the internal storage. And after returning, it will conduct analysis just to tell whether there's some problems between the master replica latency. If there's some problem with the master replica system, then it will select a system with the least latency to switch it. And also, if this master replica is dead, then it will trigger a switching to another master. No manual intervention is required in the process. Another component used internally is our mall. So for our business launching, there are two steps. The first step is the request. So during request, the data warehouse resources will be allocated, for example, how much CPU, how much internal memory. So that's normally what we do. So after the request, the project manager will approve on the request. And after the approval, based on JD's resources, there will be a DBA approval. And after that, there will be an online database will be created. And the way we create the table is similar, including the request table, approval table, and DBA approval based on their own professional knowledge to evaluate whether the table's creation has some risk factors, whether it's compliant with regulations. And after that, the online table will be created. And after the creation, there will be some more interfaces in KBS to apply for resources, scheduling, etc. So the process by creating the table is not too difficult. It's just a database creation. But to change the structure of the table is not that easy. For our R&D people, they have some knowledge about database, but their understanding is somewhat different from ours. We know that for some business requests, there are no primary keys. This is what we are not recommending. Or maybe the primary key is not auto included. We would recommend the auto inc function. Or maybe there's some deprecated storage engine or deprecated characters. Or maybe he has created a table and created another one. But the table actually already exists and there's some data in the table as well. So now they're using a dump sequence to delete it. But this is a risky behavior. And there are some even lower mistakes, like a syntax error. So these are common problems and unavoidable. Next. Some of the users, they don't use Vitess. And based on Vitess, we can do some interesting things, just like I mentioned. By creating the table, there might be some issues, for example, syntax error. Windex has one advantage in that there's a very good modular-based system with very low coupling level. So we don't need to change the modules, even if there's some syntax errors in some modules. But because of the low coupling level, for example, I can introduce the tabular modular to create a tabular. If there's some syntax error, then I can tell the business department that there's a syntax error in the SQL, so there's no need for PM and TBA approval to identify the error and eventually resubmitting the request. And some of the tables, primary keys and other restraints, like if there's no syntax error in a SQL after analysis, then I can acquire the name of the table, the list information, the primary key information. All this information can be acquired by then. Similarly, I can execute it online, a short table sequence, and then I'll look like whether there's a table online. If yes, then I'll tell R&D that your table already exists. No need to submit again, or submit the SQL again. Or that if the table does not exist, then following these rules, I can examine it and verify these master replica information, or whether these SQLs are compliant. It's very easy to deliver these functions. Next, I'd like to for people interested in Vitess or potential users of Vitess, some advices. My first advice is based on the example I mentioned, the reusing of Vitess code. Even if we don't use Vitess services, we can still use Vitess code for some of our in-house development. For example, the parcel module. Actually, in China, there are many teams are doing that, using the parcel module of Vitess. Besides, while doing resharding, they will first extract the bin log and translate it into MySQL. So all these related modules can be easily accessed and utilized. And also some of the existing MySQL modules, they are not coupling with the business logic of Vitess. And second, let Vitess run at the lowest R&D cost, because it's based on Kubernetes, and it's a database and cloud solution. One friend of mine, he's using Vitess and intends to run it in an official way, but some of the big teams have a QBS experience and data center establishment teams experience, but some smaller teams, they have never used the QBS. So let's take step by step. Vitess can run KBS, but the first step should be, on some of our existing Docker or physical servers to run Vitess first. This is easy to do, and after that, we can provide online production services. And the next step would be further development, integrated development. Thirdly, especially for OM, the code may have some bugs, and the operation maintenance may be mishandled. But don't let a problem affect all your services. Especially if the service is big, like hundreds of businesses are sharing the same module. Then if one procedure is mishandled and it affects all the modules, it will be disastrous. Now, my fourth advice is to split large clusters into multiple small clusters. Now, JD is using the largest Vitess cluster in the world. If you are walking in advance of, you're taking the lead, you will encounter problems that no one else has encountered. If you don't want to invest in R&D to solve the problems, you can split your large clusters into multiple smaller ones to avoid unexpected issues. Later on, my colleague Mr. Jinke will share problems and solutions. Good morning. Just now, Mr. Xuhaihua has shared the first and second part, and the third and fourth part, because of the time restraint, I'll quickly go through them. So I'll talk about what are some of the problem solutions JD has encountered and adopted, and next I will share our future plans. I'll start with challenges encountered. JD is operating, fair to say, the largest in China Vitess cluster. Probably we are online. We have over 20,000 EP tablet base and around 3,000 EPS, and we have the largest VTK cluster around 400. So in operation, in running, we have encountered many problems.
So first of all is the various demands, and some will say that we have a lot of things that is not supporting. And after we find out these problems, we are going to manage all of these demands, and also the influence between different apps, because it's the shared clusters, so they want to have some priorities in these clusters. So during our operations, we also expected that there will be some problem happen in our topology services. For example, the metadata is too big. Sometimes it will have some OOM. So when we commit to the gateway, the VT gates, because we have a lot of users, so how can we upgrade these VT gates, etc.? It's all challenges for us. First of all, I'm going to tell you how we solve these problems. It started from the very demand, because it's based on the Vitess 2.0 version, and we also have some custom modification on JD and define some of the log and prepare protocols, and also have support some of the more complicated operations. And we found the bugs on the Vitess. There were some of the leakage in it. Later we are going to provide the PR to the officially. And next is about the big value. We are going to and link the etcd to Redix. And as for the upgrade of the VT gate, we are going to utilize its characteristics to do some of the unaware upgrades on the client side. Because we have provided different kind of accounts like RWRORS, so we can some of them can read directly from the warehouse, so it can separate their readings, so that it will avoid some of the problems happen to the gateways. And also we will provide specific VT gates to some of the big demand nodes in the clusters. We also have very detailed monitoring, and we also want to do some more convenient operations on resharding and do the scheduling more intelligently and migrate from 2.0 to 3.0, because originally working on the 2.0 and 3.0 are able to satisfy more demands. Just now we have talked about monitor everything, so we want to include VT tablet in MySQL, etc., so that we can provide better, detailed, and accurate demonstration, etc., to the users. And for the original UI and for the DBA, we need to simplify some of the operations. As for intelligence scheduling, it's very interesting for us, because we're using some of the machine learning algorithms to include some of the resources needed by the users, including some CPU to do some scalability work, so that it can save some of the costs of our company. And later we're going to migrate from 2.0 to 3.0. So So this is the work we need to do. Today, we are very honored to come to share with you together with my colleague. And during the utilization of Vitess and JD.com, we have get a lot of help from our team and also from our friends as well. And I also want to thank the Vitess team. Thank you for all your support. Next, we're going to hear more speeches from the Vitess team, and next is their time. And if they are on SE16, on the booth SE16, and you can meet with us there to